Welcome to This Explainer. Today, we're unpacking the completely fascinating world of producer behavior. Have you ever wondered how a business actually decides exactly how much of a product to make? Well, we're going to ground this entire economic theory in a journey that's pretty relatable, the journey of a simple pen maker. By the end of our time together, you'll understand exactly how producers respond to price changes and market shifts. Here's our roadmap for today. 1. Core concepts of supply. 2. Mapping the supply curve. 3. Movements versus curve shifts. And 4. Elasticity of supply explained. Let's dive right in. Section 1. Core concepts of supply. Let's establish the foundational rules of producer behavior. To kick things off, let's ask the core, intuitive question at the very heart of this explainer. Why do producers supply more when prices rise? Well, it all boils down to the ultimate goal of basically any producer, right? Maximizing profits. Profit is simply your total revenue minus your total cost. Since total revenue is the price of the product multiplied by the quantity you sell, a higher price naturally means more profit, assuming, of course, all your other costs stay the exact same. This direct relationship where higher prices lead to higher quantities supplied is what we call the law of supply. But to really wrap our heads around this, we need to be pretty precise. The economic definition of supply isn't just about goods existing somewhere in the universe. It is the exact quantity of a commodity that producers are actually willing to produce and sell at a given price per unit of time. Notice those three absolutely crucial dimensions. You need a specific quantitative amount, a specific price, and a defined time period. So just saying producers supply 1,000 blankets kind of means nothing in economics. But saying producers supplied 1,000 blankets at a rate of Rs 500 per blanket during December 2020, now that is a complete, usable statement of supply. A really crucial point here is understanding the difference between stock and supply. They are not the same thing. Stock is just your potential inventory. Think of it like dusty boxes sitting in a warehouse with zero time dimension attached to them. Supply, on the other hand, is the actual flow of goods rolling off the conveyor belt and reaching the market for sale over a specific period. For durable goods, your supply on any given day is usually just a tiny fraction of your total stock. Now, let's peek at the math behind the curtain, the supply function. This shorthand equation looks a bit like alphabet soup, but it simply shows us that the quantity supplied, QS, is a function of numerous, totally interwoven market variables. It's not just about the price of the good itself, which is P1. It includes the prices of all other commodities, the prices of your factors of production, the current state of technology, the producer's objectives, and a bunch of other external factors. Let's decode that mathematical formula into plain English. What's really interesting about these determinants is how they directly drive our pen makers' everyday production decisions. If the cost of production, say the plastic for the pens, goes up, profit margins shrink, so supply naturally drops. If the price of another good, like pencils, suddenly skyrockets, our producer might actually retool their factory to make pencils instead. An upgrade in technology could lower costs and immediately increase supply. Even the producer's internal goals or their expectations of future market prices play a huge, defining role in how many pens actually hit the market today. Section 2. Mapping the supply curve. Let's visualize our pen producer's choices. Take a look at this supply schedule. A supply schedule is simply a list of different prices alongside the exact quantity a producer is willing to supply at each of those prices over a set time frame. So here, when the price of a single pen is Rs2, our producer is perfectly happy making 20,000 pens a month. If the market price bumps up to Rs3, well, they're willing to supply 30,000. And at Rs4, they ramp up production all the way to 40,000 pens. It's a very clear, direct, and positive relationship. So let's take those exact schedule data points and actually put them on a graph. With price on the vertical y-axis and quantity supplied on the horizontal x-axis, plotting those points reveals this classic upward sloping line. We call it S. This is our supply curve. The upward slope visually proves the law of supply we talked about. Higher prices consistently lead to greater quantities supplied, assuming all those other background factors remain completely constant. Section 3. Movements versus curve shifts. This is the crucial difference in how markets react, and honestly, it's where a lot of people get tripped up. We have to explicitly distinguish between these two terms, a change in quantity supplied versus a change in supply. I know they sound virtually identical, but they map out entirely different business realities. A change in quantity supplied is caused strictly by a change in the product's own price tag. That is it. But a change in supply, That's caused by structural changes in the underlying business environment, like those determinants we discussed earlier, a leap in technology, shifting production costs, things like that. Let's look at the first scenario visually. When we have a change in the commodity's price, and strictly the price, we merely glide up and down the existing supply curve. Notice how starting from the middle point, if the price drops to RS2, we literally just slide down the curve. This is called a contraction of supply. If the price jumps up to RS4, we glide up the curve, which is an extension of supply. Notice that the line itself hasn't moved an inch. We are literally just reacting to the new price tag. But what happens if a non-price factor changes? Say our pen maker goes out and buys a revolutionary high-speed assembly machine that absolutely slashes costs. Because of this, the producer will now supply more pens at every single price point. We literally pick up the entire curve and move it to the right, creating a brand new curve. This is an increase in supply. On the flip side, if factory rent suddenly doubles overnight, profitability plummets. At every given price, the producer will make fewer pens, shifting the entire line to the left. That is a decrease in supply. Section 4. Elasticity of supply explained. Now we're shifting gears to measure the responsiveness of these producers. To accurately measure this responsiveness, economists use a concept called the elasticity of supply, or ES. The formula shown here is your ultimate tool for this. It's simply the percentage change in the quantity supplied divided by the percentage change in the price. It tells us the precise mathematical sensitivity of the producer to shifting market prices. Let's ground that math in a concrete example so it makes sense. If we run the formula and get an elasticity coefficient of 1.2, what does that actually mean for us? It means that a 1% increase in the price of our pens triggers a 1.2% bump in pen production. Because the quantity supplied changes by a greater percentage than the price did, we call this an elastic supply. In short, the producer is highly responsive to the market. Based on this math, we actually have 5 distinct states of elasticity, and they dictate the exact steepness and shape of our supply curve. If S is greater than 1, supply is elastic. If it's exactly 1, meaning a 10% price bump yields exactly a 10% supply bump, it's unitary. If it's less than 1, supply is inelastic, meaning producers are kind of slow to react. At the absolute extremes, S can be 0, which is perfectly inelastic, represented by a rigid vertical line where quantity never changes regardless of price. Or S can be infinity, which is perfectly elastic, forming a completely horizontal line. So, what actually decides whether our pen maker is highly elastic or totally inelastic? It relates right back to real-world limitations. The biggest factor is time. In the short run, if pen prices spike tomorrow morning, you can't just build a new factory overnight, right? So supply is inelastic. But in the long run, given enough time, you can expand your facilities, making supply much more elastic. Other determinants include how rapidly your production costs rise as output increases, how complex your manufacturing techniques are, and your expectations of future prices. And that leaves us with a truly powerful thought to wrap up our explainer today. If you know a product's supply elasticity, if you know exactly how fast producers can spin up their factories when prices spike, or how trapped they are by complex manufacturing techniques, can you predict tomorrow's market shortages today? Mastering the mechanics of supply and elasticity literally turns us from passive observers into powerful market predictors. Thank you so much for joining me on this explainer today, and keep looking for those hidden structures shaping the world around you.